Assalamu alaikum warahmatullahi wabarakatuh, dear students. This is Dr. Ali El-Moursy, and we are in the last lecture, the last part of the last lecture, lecture number 30, and this is part 2 for Digital Logic Design DLD class. This is, inshallah, will be the last lecture in the semester, and it is discussing the BCD counters and the 7-segment display. In the last lecture, we talked about the BCD as a binary representation, how to represent the decimal numbers using the BCD representation. And today we need to discuss something else, which is the BCD counter. We discussed the BCD counter in lecture number 28 for the counters. When we talk about the counters, we mentioned that we have different types of counters. One of them is the BCD counters. The BCD counter, it's counting in BCD. What does it mean by counting in BCD? It is a binary circuit. So we build it as a usual counter using flip-flops, okay? But once I mention this is a BCD counter, this indicates to me all the information that I need regarding the counter. We mentioned before, in order to design a counter, I have to answer 4 questions. Do you still remember them? Okay. In order to successfully build a counter, I need to know, number 1 is the range of counting. Since I'm building a BCD counter, since I'm building a BCD counter, so automatically this counter, so the range of counting is the range of BCD. What does it mean by range of BCD? Means my target is to count for decimal. So that means the range of counting is from 0 till 9, and automatically the counter go back to 0. But we answer the first question for the BCD counter. Then next question is the sequence of counting. Of counting. BCD counter by default counts sequentially. Means there is no hopping, there is no skipping. So from 0 I go to 1, from 1 I go to 2, from 2 I go to 3, blah 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 blah. Okay, and from 9 I go back to 0. Okay, but this is the second question we answered. Third question, direction of count. This is up counter. Very clear, مش كده? Agree? Now, question number 4 is the trigger of counting. Trigger of counting. This is self-triggered. So I answer the 5 questions. That means I am ready for designing the BCD counter. Okay? Can I build the BCD counter? Yes. How? State diagram. Okay? How many counts, the range of counting, and the sequence of counting is tell me how many counts do I have here? I have for total 10 counts. And this is a direct hint for me to build the sequential circle, the state diagram, okay? So that means how many circles do I have for my counter? I have 10 of them. I have 10 counts. Count. So I have a state for count 0, call this 0, S1, S2, S3, S4, S5, S6, S7, S8, and finally S9. 10 counts means 10 states. Now, the sequence of counting, I go sequentially up. So, trigger of counting, how many? Do I have any external input? No external input, so I have only one arrow from one count to the next. So from S0 I go to S1, from S1 to S2, from S2 to S3, to S4, to S5, to S6, to S7, to S7, 8, to S9, and then from 9 to 10. So this looks very similar to the binary counter that we built, the 3-bit binary counter that we built before. However, this counter is not counting from 0 to 7. This counter counts from 0 till 9. How this will make any difference? Now, in order to design the circuit, I will not design this circuit. I will leave it for you as a homework. Okay? So, you have to design in full this circuit till the end of the design using T-FIFI, T-flip-flop. Homework. This is, by the way, it will be an assignment, not an homework. We'll put it in the assignment part. Okay, I will post it on the assignment part. So I will put it with a deadline. You have to do the design and send it back to me. Okay, so this is assignment number 2. Make the full design for a BCD counter using T flip-flop. I will post it, don't worry. But before we post it, how this is different from our design for the binary counter? The number of states. Okay, here I have how many states? I have 10 states. Okay, so you go ahead and build it. Okay, here, once we build the state diagram, we will go identify how many states, accordingly, how many FIFIs, the type of FIFIs, start the design. From state diagram, we can build the state table. From the state table, K-maps, get the state diagram, get the state equations. From the state equations, we can draw the circuit. I will leave this design in full for you as one of your assignments. Agree? Make sense? Okay, I may even add. Okay, well, let's leave it as it is. Let's leave it as it is. Okay, you will read, by the way, the assignment number 2. You will read the specs of the assignment and you go and solve it. Okay, agree? Now we already designed the BCD counter. What is the usage of the BCD counter? Do we have a practical usages of BCD counter? The answer is yes. Okay, and now this moves us or shifts us to the next thing that we need to discuss today, which is the 7-segment display. Okay, so assume that you already finished your assignment. You already designed this circuit, which is the BCD counter. Okay, after going through your steps of design, you will end up of a circuit, and this circuit is actually, we can have a block diagram for the circuit. Keep as a block diagram for the BCD counter. If it is self-triggered, do I have here any external input? The answer is no, but the circuit has an output. How many outputs for this circuit? The output of the circuit will be the outputs of the flip-flops as you design it. Let me solve this for you in order to show the circuit. Okay, so here I have 10 states. How can I achieve 10 states? How many flip-flops do I need? Can I use one? One flip-flop will give me 2 states. 2 flip-flops will give me 4 states. 3 flip-flops, the 3-bit counter that we will give me up to 8 states. Here I need 10 states. So the minimum number of FIFs to use, I have to use 4 flip-flops. That means each state here will be defined by 4 outputs of the flip-flops. We can call them A, B, C, and D. So I have here A, B, C, D, 0, 0, 0, 0. I have here 1, 0, 0, 0, 0, 1, 0, 0, 1, 1, 0, 0, 0, 0, 1, 0, 1, 0, 1, 0, 0, 1, 1, 0, 1, 1, 1, 0, 0, 0, 0, 1, and finally 1, 0, 0, 1. I define the states and I define the state inputs, which are the state outputs as well. Yet after I design the circuit, I will end up of this block for the BCD counter that has how many outputs coming out of the FIFs. They are outputs A, B, C, D, which are representing which count I am in for the count. Agree? Now, how can I utilize this? The BCD counter can support the digital clock that we have discussed before. In the digital clock, we discussed the digital clock in the counter, okay? Do you still remember the digital clock? We discussed before, the digital clock has how many counters? The digital clock has actually the digital clock, there are many designs for digital clock, but the digital clock has 1, 2, 3, 4, 5, 6. I have 6 counters. 6 counters. I have 2 counters for the seconds, 2 counters for the minutes, 2 counters for the hours. You agree? Now, we discussed before those counters. Do I have any of those counters, BCD counters? Yes. Which counters are the BCD? I have this digit. I have the first digit of the seconds, the first digit of the minutes, the first digit of the hours are BCD counters. Agree? We already will be able, through our homework, to design this counter. So the counter will look like this. It's a circuit. This is the block diagram for the BCD counter. It has no inputs because this is self-triggered. It has only the clock. Definitely, I have here inside I have flip-flops. So the flip-flops should be connected to a clock. If a self-triggered, self-triggered counter. Okay, the clock will order the values here to go from 0000 to 1000 and so on. Now, how can I connect the counter to this? This is what we wanted to talk about today, okay? As to complete the picture. First of all, we want to learn what is this. This unit is called 7-segment display. What is a 7-segment display? 7-segment display is an output device. 7-segment display is an output device. Why we call it 7-segment display? Because it has 7 LEDs. 1, 2, 3, 4, 5, 6, and 7. By changing the value of each segment, I can display the different numbers or characters. So first of all, that's why it's called 7-segment display. But 7-segment display is an output device. It's actually 7 LEDs. By lighting or dimming those LEDs, I can display the different numbers. So right now, if I give those LEDs some identifiers or names, I will call this A, B, C, D, E, F, and G. Now, in order for you to display number 2, I will light everything except F and E. If I want to display number 1, everything should be dimmed except D and E. If I want to display 3, everything will be on except F and G. For 5, everything is on except B, D, and G, and so on. So this device is called what? It's called 7-segment display. How many of them? We have 6 of them in our digital clock. Okay, the purpose of the 7-segment display is to display for you the different numbers. I can use the 7-segment display to display the decimal numbers. Correct? Right. The point here is that how can I link between the BCD counter and the 7-segment display in order to display the 10 different numbers of decimal from 0 till 9. Okay? From 0 till 9, this is 0, this is 7, this is 5, this is 3, this is 1, this is 2. I can also display 8 by turning everything on. I can also display 9 by turning all on except this. I can also display 6 by turning everything on except this. So using the 7-segment display, I can display any of the digital or any of the decimal numbers. Okay? So today we wanted to learn. So now we learned what is the digital, what is the BCD counter. The BCD counter is producing 4 binary values for the number to be displayed. So for number 0, here I will have 0, 0, 0, 0. But I wanted to convert all zeros out, the output from the BCD, يعني for the count, what we call the count 0, the outputs of the flip-flops will all be zeros. I want to convert this binary, all zeros, to translate it to everything to be on from A till G except the middle one. How can I do that? I can do that through a combinational circuit called what? Called 7-segment display decoder. يبقى here we will put a decoder. It's called 7-segment display decoder. This 7-segment display decoder will take as an input the output from the BCD counter and will produce as an output ايه بقى؟ will produce as an output 7 signals for the 7-segment display device. or output or LEDs. Call it whatever you want. يبقى here I will have A, B, C, D, E, F, and G. يبقى 7-segment display decoder is taking as an input the output from the BCD counter, and it will decode it to drive the 7-segment display in order to light on or dim the different LEDs to display for the end user the different numbers of the binary, of the decimal. Okay? So now, my question. Okay? My homework. What's my homework here? My homework here is for you to build this device. يبقى this is the first part of the homework, is to build the BCD counter. The second part of the homework is to build the 7-segment display decoder. How can I, first of all, is this a combinational circuit or sequential circuit? No, this is combinational circuit. A sequential circuit is the counter that actually gives me 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 1, 1, 0, 0, and so on. Okay? Automatically. Every second, it will give me for this. Every second, it will give me the different number. Now, I want to translate the number here on the bits here into an output to the 7 display. So, this is a combinational circuit from chapter 4. So how can I design this combinational circuit? This combinational circuit consists of inputs or outputs. How many inputs to the 7-segment display decoder? These are 4 inputs. اللي هم مين؟ A, B, C, D. In any order بقى. Okay, we put the order opposite. خلينا نمشي with the same order that we already used. Okay, يبقى A, B, C, D. And I expect here to see all possible combinations of A, B, C, D. No, I will see only the combinations for the numbers starting from 0, 0, 0, 0 لغاية مين بقى؟ The last thing that I care about here is the value for the A through D, the value 91001. For each of those, I want to produce outputs. How many outputs? 7. Those outputs are the outputs for the 7-segment display. A, B, C, D, E, F, and G. If I wanted to display number 0, I need everything to light up except the segment B. So all segments should be 1 except segment B. Because B is the segment in the middle here. Let me redraw the 7-segment display in A. This is the 7-segment display. In order for you to follow the names, okay? I will just show here. I will show that number 0 is A. Number 0. No, this is number 8, not number 0. Now I am displaying the number 8. Okay? The names of the segments, this is segment A, B, C, D, E, F, and G. So in order to display 0, everything should be light up except B. In order to display 1, I need only D and E. D and E ones, and all the rest are zeros. How to display number 2? Number 2, light everything except mean, except F and E. يبقى F and E are zeros والrest are ones. Can we continue? Complete this table? Yes. After finishing this table, I have to design. How to design? This is a combinational circuit design. Starting with TT. From the TT, I can make a K-maps. How many K-maps do I need here? I need 7 K-maps because I have 7 outputs. A, B through G, each of them should have a different K-map. Agree? Now? Okay. So now I need, what is the size of the K-maps? These are 4 variable K-maps because the inputs are A capital, B capital, C capital, D capital. Okay. So I have 4. I have 7 K-maps. Each of them is 4 variables. Draw the K-maps, simplify the K-maps, get the equations, do the implementation using 2-level NAND. And this is your next assignment. So the next assignment is to do 2 designs. A design for the BCD counter. This is sequential circuit. And a design for a 7-segment display decoder. This is combination. Okay? So once you make this design, that means you have put the first parameters or the first item that you can use for building a full digital clock. Agree? Easy, simple. The specs for those problems will be posted to you, inshallah, on the blackboard. And now this is the last thing. By the way, you will see the 7-segment display and the 7-segment display decoder and the BCD counter, inshallah, when you go to the D&D lab. So that's why I want to introduce this to you. I want you to be trained on this before you go to the digital logic design lab. Okay? But you will see those devices and you will utilize them, inshallah, in the lab. At this point, we have finished all the material that we have for the digital logic design course. I hope that you enjoyed the course. This is lecture number 30, part 2, and this is the end of the class. And we finish all of the material. I hope you enjoy the material and see you, inshallah, in the upcoming courses. If you are a computer engineer, you will come to see me, inshallah, in the microprocessor class. If you are an electrical engineer, we may meet later on in a maybe elective course or some compulsory courses. I hope you the best of luck and thanks a lot, and see you, inshallah, in the next semester.